Good morning, everyone. Today we are going to talk about how attribute-based access control can solve different customer use cases and be the future of FGAC in security plugin. So I am SDM from OpenSearch Security. My name is Prabhat Chaturvedi, and I have along with me Shikhar Jain, who is Senior Software Engineer, OpenSearch Security team. To start with basics, what is authorization? So authorization is a process of granting the requester the ability to access a resource based on permissions which the user has. So let's take a case of an airport. Or before going to airport, you need to have a passport. The passport, the process of giving passport to you is called identification, identifying you as an individual, printing the passport, creating your profile. Only once the identification is done, the next process is when you reach to airport, the security guard would stop you, check your face, and if that matches with your passport, that process is called authentication. Once your claims are verified, you're let into the airport, but the visa on your passport helps you get the authorization to travel to that particular country. That process is called authorization, whether you have permissions or not. So finally, you're able to travel to that particular country, which is like access the resource in our IT terms. But post that, everything is being tracked for accountability and auditability, such that all the access is recorded. Now, why is authorization important? It ensures proper access control, which means only on need-to-know basis, the access is granted to a resource. If you're no more in need of an access, the access is not needed, and your permissions may be removed. Next, it maintains data confidentiality and integrity, which means only the people who are allowed to view and access a resource would be able to see the resource. That's called confidentiality. And integrity means only the authorized user should be able to change a document or resource, and that claims integrity. It also enhances the security posture of your entire system. Now, it actually, we saw in the last slide, it supports accountability and auditing. As each and every action, the authorization will be checked. So that's an opportunity to track those requests and make the person responsible in future, and also do the auditing. It enables granular access, which means you can group things together as a group, users, and all those things, and it can make it more granular. It improves operational efficiency, which means lesser tickets, which amounts to lesser time spent on unknown events and untraceable events. So your IT team has lesser load. Last but not the least, it facilitates regulatory compliances, such as HIPAA, FIPS, and others, where you need to explicitly show that you are implementing proper access control mechanisms for compliances. Okay. So what is the cost if I don't implement authorization, and what is the total cost of unauthorized access? Can anyone guess what was the total cost of breaches globally in the last year? Was it millions or billions? So some rough numbers. 1 billion. I think you are close, but not so close. It was 10 billion. The total estimated costs of the breaches globally last year amounted almost around 10 billion. The breaches, whenever they happen, the average cost of a breach amounts to almost 5 million. And if that happens in cloud, it even crosses beyond that. All these breaches amounts to fines as well, especially in Europe. This is called GDPR. Last year alone, it was amounting towards 2 billion, which is 14% increase year on year. Now, let's see the timeline of authorization, how this authorization has evolved over time. The first access control which came in was discretionary access control, which means that it was the only access control which came in when Unix systems came, where the user who is the owner of the file would decide who all have access on the discretion of that owner. So and it can be grouped together. The users can be grouped together, but only the owner has to decide. Somewhere around 1970s to 80s, the next decade, the introduction of MAC, which is mandatory access control, happened. It was a more stricter security control by government bodies and military bodies. And it was then a user, it was an authority which made this. So the authority would decide the clearance level of documents, the clearance level of the users, and finally, only those particular users would be having access to those confidential, unrestricted data. Some examples of them are like Bell-LaPadula model, which was for confidentiality, and BIBA model for data integrity. Next, due to the emerging need of the organizations and the scalable solution, the RBAC came into picture, which is called role-based access control. It is where the group of users or users can be grouped together and the permissions can be grouped together, and permissions and groups were mapped. It was much more scalable, and it didn't need individual level access control. So most of the industries have been using RBAC. It is the most widely adopted access control currently. So then, as we matured, there was a need to bring in other attributes, user attributes, environment attributes, resource attributes, and all those things together along with the actual role of the user was clubbed together to identify the need of the user to finally access the resource. So another example can be, for example, a document might depend on user's department, the security clearance, and also the time of the day before giving the access to the user. There came in as an extension of ABAC, which is tying the attribute-based access control complex use cases into a policy. And a policy-based access control gives more fine-level control on ABAC use cases. An example of that can be that allowing access to resource only during work hours, and only if the user has passed multi-factor authentication. You can marry many different use cases together in a policy, and it becomes scalable for enterprise use. The much more latest use case has been relationship-based access control. It is more suitable for social media or social networks sort of use cases where the relationship of the user with the resource or user to user is being defined, and the access control is being defined there. So each of these models represents an evolution towards more dynamic, scalable, and fine-grained access control mechanisms to meet the growing complexity needs of IT. Now, what's ABAC? So the user attributes, who the user is, who, what, how, all those attributes can be pulled in, which defines the user, which happens in RBAC, basically, plus the context of what the user is trying to use. It can be resource-based, actual values of the resource, or it can be the delegation. It can be the risk which is coming up. Maybe you change some location. It can be the clearance level of the documents. It can be the classification of documents, relationship between the user and the resource, or it can be some membership. There comes an environment, which means which place you belong to, what is the system variables, the time of the day, the region which you're traveling to, or IP addresses, or packages, or the device which you're using, maybe mobile device or laptop. All of these can be clubbed together to make a decision based on some rule engine. The rule engine refers to rules, which defines so-and-so access should be granted to so-and-so user based on so-and-so attributes. And finally, the access is being granted or denied. So let's see what is dynamic authorization. The process of externalizing the access control out of your system to an external central decision point, which separates authorization and policy management outside the application lifecycle, is actually called dynamic authorization. So let's take an example of a user trying to access a resource. So the security guard comes in and preempts the access and to enforce a decision. Before enforcing decision, it has to go to to get the decision. So this particular component is called PEP. It is an enforcement point. Before enforcing the decision, the security guard needs to know the decision. So the decision is being computed at the policy decision point called PDP. PDP, to execute the decision, needs to get some values or policies These policies are evaluated in PDP, but pulled in from PAP. PAP is policy administration point, nothing but which maintains the life cycle of policies documents. You can manage policies, create, delete, and create many other based on department and all. The policies, when pulled up in, there are placeholders where these attributes have to be uh, induced from the external systems, like we discussed in the last slide, the user attributes, contacts, and environment attributes. Once the decision is computed, is told back to the PAP, PEP finally grants the access or denies to the particular resource. This entire thing is also called policy-based access control. Tying the ABAC into policies to solve complex use cases is called PBAC. Now let's see some of the complex use cases which can be achieved through ABAC. The first one is a medical use case. Like only doctors, for example, I being a patient, only my doctor should be able to view my records. Or in other words, doctors can view medical records of any patient in their department or the patients directly assigned to them. This complex use case can be achieved through ABAC, but may not be achievable through RBAC. The next one is normal enterprise use case that manager should be able to see only employees under or details of the employees under them, or maybe approve a leave. The third one is a financial use case where cashier should be able to operate the cash box only during the daytime on the business hours and not allowed after hours. If at all, in some emergencies, can pull in maximum 1,000 USD before 8 p.m. Right? Okay, let's see some of the predictions of ABAC adoption in the market. So 13 to 18% is the expected growth for next 5 years of ABAC CAGR, which means the domains like finance, healthcare, and cloud services, where such complex use cases arise, they are the ones who are going to lead this adoption. By 2025, the total adoption of entire enterprise and all the big enterprises is expected to be 60%. And when an enterprise implements ABAC, there is generally a reduction of 20 to 30% of security breaches. This is an average number. Some companies may have better numbers. Now let's see how RBAC and ABAC differs. Generally, RBAC is coarse-grained. Once you give an access to a resource, it is valid throughout the life cycle. ABAC, it is dynamic. It can change based on time instant, based on the location, and so it is very fine-grained and in dynamic. RBAC is static, role-based, and ABAC is dynamic. It is also policy-based. Policies can be defined. RBAC is based on roles alone, and ABAC brings in other attributes, conditions. It can be your LDAP stores. It can be many different external systems from where you can pull in the attributes. And there's a known problem with RBAC, which is called role explosion. As and when there's a new use case which is onboarded, you generally have to create a new role or group roles together to another role. That role management becomes very difficult, and it's called role explosion. That is solved by implementing ABAC. Probably, if there are 100 roles, you can manage them with one simple ABAC policy alone, given that you have dynamic attributes coming in. The RBAC systems used to be simple and very static, but ABAC is dynamic and can solve complex use cases, which we saw. Those were the simple complex use cases, but there can be very complex use cases which ABAC can solve alone. Now let's see a brief of a little bit on PBAC. So PBAC is nothing but bringing up ABAC rules together into a policy. It is also called policy as a code, which means it is readable. It decouples from the earlier code. Previously, the authorization rules and logic was very connected between the code. The developer had to know about all those. Now, developer need not know, and the business owners need to know. So it's decoupled, easier to manage and update policies, and it directly converts from business requirements to English language. For example, we say that English is the new AI, new coding language after AI. Similarly, policies is a language which business owners can directly provide in English, can be converted to policies, and developer need not even care about it. It improves the performance by externalizing the policy evaluation from the application to a dedicated policy engine, which means if you want to scale up your policy engine or decision engine, you can scale it up. Maybe your application is scaled down because you have a lot of different policies being executed. And finally, it is readable. Any person can read it if they know it. It can be easily converted to English language. So these are some of the implementations of PBAC. It goes back to SAML world. The analogous to SAML protocol is called XACML, Extensible Access Control Markup Language. And it was open source. It was XML based. It was heavy. There come the need of some JSON based light level protocols. OPA is one such called Open Policy Agent. It's open source. It's a Rego policy based language. There's CEDAR, which is open source, managed by Amazon, and already adopted by Amazon verified permissions. And the next coming up one is OpenFGA, open source yet again. It is based on RBAC than PBAC alone, and based on the relationship between the object and the user, and inspired by Google Zanzibar's white paper. So Google Zanzibar is the Google's global authorization system, and it is not open source, but Google produced a white paper based on which this has been made. SpiceDB is also inspired by Google Zanzibar's white paper, is also open source, but this one is graph-based. So graph-based, access-based control is much suitable for RBAC use cases where you can define relationship. So that's it from my side. I'll hand over to Shikhar, who will talk about security in OpenSearch.
Hello. Hello. Yeah. Hi, everyone. I'm here to talk about security in OpenSearch. I know security is the last thing you want to hear when you wake up in the morning because we should talk about security today to avoid a data breach in future. Let's briefly glance over the features that we support with security plugin. First is encryption. So you can use the security plugin in OpenSearch to encrypt any traffic traveling to the cluster and also all the traffic that is within your cluster. This supports TLS protocol with RSA, ECDSA, and configurable TLS version as well. Second feature that we can talk about is authentication. Security plugin offers different ways to authenticate or identify your users to the system here being an OpenSearch cluster. Security plugin supports Active Directory, Client Certificate, JWT, SAML, a bunch of these open protocols. Once you have identified the user, as Prabhat earlier mentioned, we need to authorize whether the user is allowed to perform an action or not. This authorization today is built locally into the security plugin. It has its own privilege evaluator, and it uses RBAC to support authorization. As Prabhat mentioned, RBAC is role-based access control. What that means is once we have identified a user, we need to map it to a role. A role is a logical collection of permissions. So security plugin ensures that whatever is configured within the role, the user can only perform such actions. Although it's an RBAC model, a security plugin also supports finer or granular access control. You can go up to a granularity of a document or a field to ensure that your logged in user has access to whatever you configure them to. After all this is well and done, we also support, like the security plugin also supports audit logging, the failed as well as successful requests. It's also very configurable. You can send audit logs, you can write them to a local log file, send them to a different cluster. It supports different ways to extract it out. Now let's quickly dive into the request flow of what it looks like when you have security plugin configured on your cluster. For a client, it does not differ a lot. Now the client is still going to reach out to the same endpoint, the same port. They're just going to sign the request using some sort of credentials. These can be your basic username and password credentials. This can be a certificate, or this can be advanced things like JWT tokens, right? Security plugin sits within the OpenSearch process and the ecosystem. So it has an understanding of whenever a request lands on the cluster. Before even the request, if you see security plugin sits now between a logical OpenSearch and a request handler. So let's say if you're executing a search action, security plugin will ensure that the user is authenticated, authorized, and only after it is a successful authorization, the request is forwarded to the actual request handler, and the response is returned back to the user. And in all cases, again, if you have configured audit log, it will audit log the request. With this, let's dive a bit more deep into how security plugin actually functions. So security plugin has something called as a security filter. It's at, as you know, OpenSearch operates at both REST and transport layer. So we have a filter at REST layer as well as a transport layer. It is a wrapper around the actual request that ensures a compatible format for security plugin to perform authentication and authorization of the incoming request. So security filter forwards the request to something internally known as a backend registry. The backend registry is nothing but a configurable and a config-aware class that knows if you are configured your cluster with whatever authentication domains or authentication systems that we just spoke about. Once the user, like so backend registry, tries to authenticate or identify the incoming user with a bunch of options that you have. So security plugin supports multiple auth types, and that means you could have a basic auth user, but you can also have a JWT or a SAML user for dashboards, right? Once the requester is identified, security filter forwards the request to privilege evaluator. Privilege evaluator, as I said, it's locally sits within the security plugin, tries to get the more details about the user and maps them to the right role. The role mapping is configured in advance by the security admin of the cluster, right? So privilege evaluator, once it realizes whether the request has to be allowed or denied, for a successful request, it sends it back and the request proceeds to the OpenSearch cluster or the action handler and then to the cluster. Okay. Now that we know the privilege evaluator is the guy that can perform or adds all the authorization rules for you, how can we support ABAC use cases in security plugin? So ABAC in security plugin is supported with something we call document level security. A high level definition of the feature is you can configure dynamically which documents should be supported or readable by which user. So for example, on your screen, you can see an example for role policy, which says allow all cluster actions, allow actions on indices, which start with pub or pub, and the action is only read. But you also see something called as DLS here, and it looks like a search query where it says match the term if the readable attribute matches the incoming user.name. So user.name here is a dynamic substitution, and security plugin ensures that it substitutes the logged in user's name before submitting this query to Lucene. Interesting fact, because document level security now directly interacts with Lucene, it does not give a bad performance penalty here, right? More advanced use cases or real day life use cases we can think of are, let's consider if you are building an e-commerce website and you have a B2B use case where merchants logged in to your website should only be able to see the products they have uploaded, right? So two ways to solve it, right? You could configure an index, configure a role for each merchant that logs in or you could onboard, and then they are always mapped to the same index. So they have access only to their own index. This is role-based access control. But let's say your business booms up and you have thousands and thousands of merchants. The onboarding process becomes tedious, right? You have to manage all these 1,000 roles. It becomes error prone. As Prabhat earlier mentioned, we could solve this using a single role with something like dynamic authorization and attribute-based access control. Let's talk about advanced use cases. So the use cases that we just discussed for a B2B use case, it's not solvable very easily or human-friendly because of the role explosion problem in security plugin today. So what we're trying to propose is a more richer authorization layer in security plugin and to support more advanced use cases, for example, time-based access control. So let's say if you want your users to only access data which were ingested in last 7 days, or maybe environment-based access control. So logged in users should only be able to see data between their working hours of 8 a.m. to 5 p.m. Okay. We went through the request flow a bit earlier and we saw that privilege evaluator is the guy that performs authorization. Let's say if we add something called something we call an authorization engine here, and if the security plugin, because it's config aware and it's dynamically reloadable config, you can forward the request and privilege evaluator can now know that this cluster has an external authorization engine built into it. So this authorization implementation can be a local or a remote implementation, and depends actually on your use case. Or it could also be something very similar to the architecture of PEP, PDP that we just briefly discussed, right? So once the entire request flow stays same for the client or for the end user, they don't even know that there's something now new trying to allow or deny access to them. let's consider what it would look like if we were to support OPA or a CDR implementation in security plugin. So let's say I was to write a OPA policy which says allow certain actions only if the document or the data that the user is trying to access belongs to their department and it belongs to the same role. So on screen we see that we are defining read, search, and delete as 3 actions, and we are defining that the data attribute should match the resource, the input user attribute should match the resource attribute, and their role and team should also match. Taking this example further, let's consider this is the data that you could have from a data system or or a live system that the authorization engine can pull from. And if we see the user Alice is attributed or has attributes tagged to them for their department and their role, and the resource like logs index and security index also have attributes defined on them. So if Alice is now trying to access logs index and it's a read action, it's allowed, right? But let's say Alice tries to access security index. Because it does not match the department that Alice belongs to or the role that Alice belongs to, the access is denied. Let's consider a different example that we briefly discussed about, right? Like let's say you want to allow users only to access last 7 days of data. So for that, I would also configure or have a time on my JSON or each document, and we could write a policy which says compare the ingested time of the document and see whether it is in the last 7 days. If the time matches, so let's take this example further, and on these 2 documents we see the ingested time was of yesterday and day before yesterday, so the access is granted, versus if the user is trying to access something within the last month, the access is denied. We could also do the same thing in a different policy engine, let's say CDR. It's a Amazon open source policy, and it works on similar lines. So you would define an entity type. Let's say I define user, cluster, index, document, fields, could be different entity types that you define. And each entity type can be tied to an action or a number of attributes that you want. So let's say if you had something like a schema like this, and you could write a simple policy which says if the resource owner matches as the principal ID, or the owner of the resource is same as the logged in user, and their department also matches to IT, something like very hard coded. Instead of if you don't need dynamic and let's say your use case is static authorization, this could work as well. I think that's all we had for today. This is an open feature or RFC where we are discussing on open source, and any feedback is welcome. Thank you. Any questions?